Today I'm going to talk about the paper named as Enhancing Automated Program Repair Through Fine-Tuning and Prompt Engineering. This paper basically deals about use of code review in automated program repair. So firstly, before we go ahead with this paper, I like to tell what is code review. So code review is a software quality assurance activity in which one or more developers try to analyze peer developer source code by viewing or reading the code parts after the implementation of implementing or fixing the code. So why do we need this code review? Previously, they have done researches with using this test suits and using this pre-trained models and using this learning-based automated code repair techniques, but they did not got huge high accuracy in terms of this big automated program repair, and hence they got an idea how about using the code review, which is generated by the humans to analyze to fix the code or to analyze how it could be modified in a better way. So that's how the code review will be used. So they have basically investigated the following questions. So there are three research questions. The first one is how the pre-trained models performs in fixing the bugs identified in the code review process. They have used two pre-trained models. The first one is CodeBird and PLBART. They both on the two data sets, which I'll be discussing later. And they have even mentioned about how effective is the automated program repair using these large language models, using the zero shot and the few shot techniques. But since you know that nowadays large language models consist of billions of parameters and have shown high performance with the zero shot as well as with the few shot, and hence they thought how about how effective it is for the automated program repair. And then they try to identify the bugs, how well they were performing with the developer's perspective. They have used two manually, with two manual developers, they have investigated how well is the bugs being fixed. So the major contributions of this paper is as follows. As I mentioned before, that they have used these two pre-trained models, PLBART and CodeT5, to check the performance between these two pre-trained models in terms of their accuracy. And they have used these two data sets. The first one is Tufano and the second one is Review4 dataset. The structure and all will be discussed in the coming slides. And the reason why they have choose PLBART and CodeT5 is that these two models have both encoder and decoder, plus they have shown great performance with the natural language and programming language tasks. And then they have investigated with two large language models. The first one is ChatGPT 3.5 Turbo version and Code DaVinci Edit 001, which is the variant of Codex for the zero shot and the few shot code repair with the help of the prompt engineering, which is now being a hot topic. And then they have manually analyzed the repaired codes in order to understand the capabilities of the learning models of both the pre-trained models and the large language models. So before I head towards the methodology, firstly, this is the data set of Tufano. This is how it looks like. So they have basically used only the Java data set, and it has been limited only with the Java data sets task. And this is just a piece of code, Buggy code snippet. So in the Tufano data set, what they have done is the Buggy code is written has this two special tokens. The first one is it's starting with the start token and ending with the end token. And this is could be simplified is the code review, and that's how the code is being fixed. And similarly, the review for repair data set, which is also the same, but just the difference of the start, the special tokens, the start and the end. In there, they have used start focus and end focus, which I'll tell in details later on. And moving towards the background of the zero shot and the few shot prompt examples, I guess you all might be knowing, but just for recap, for the zero shot prompting, you can see from line number 13 to 24, what they have done is they have just given the Buggy code, and they have just with the review mentioned, they have just given the code review given by some of the developers, and then they have just written that refactor the buggy code using the review without comments. And similarly, like for the few short examples, we have to give examples to the large language models in order to predict it in a good way. So what they have done is they have used just three buggy codes along with the review and the fixed code examples, and then they have used the zero shot prompt as it is. So 1 to 24, line number 1 to 24 is just the example of few shots, and line number 13 to 24 is the example of zero shot. So coming towards the methodology, briefly, if I talk about the methodology, first the developer commits the buggy code, and most of both the data sets are taken from the GitHub and the Gerrit. And then they used to fix the code based on the review in order to get the fixed code. And here the reviewer, because we need the code review also. So here the reviewer writes review based on the code, how it could be modified, and the code review is given to the dataset. So the dataset consists of the buggy code, fixed code, and the code review. So they have, as I mentioned before, that they will be referring to three research questions. The first research question is how well is it performing with the pre-trained models. So the pre-processing will be done with the PL-BART and code T5, and they'll fine-tune these models, and then the fixed code is generated. And for the research question number 2, they have used this large language models in order to check how well they are performing. So as I mentioned, they have used code ChatGPT and Codex variant. So the prompt engine, first they input the prompt, and then the large language model is predicted, and they apply the heuristics, and then the fixed code is generated. And lastly, the third research question was like how manually analysis. So the developer tried to analyze how well the code review is being answered or being referred to while predicting the fixed code. So moving towards the first research questions, but before that, let's just talk about the data set. So with the data set, there are two data sets. The first one is Tufano and the review for repair that I have mentioned earlier. So in here, in the Tufano, it consists of 17,194 samples of the buggy code and their corresponding fixes and the code reviews. And each buggy code has like two special tokens, like you have seen with the listing one example, that it starts with start and the end. And the entire buggy code, along with the code review, is fixed into the single line where it has two special tokens again, like this. I think the internet issues. Am I audible?
Yes.
So repeating my statement, that the whole buggy code is and the code review is combined into the single line using the start command and the end command tokens. And similarly, this review for dataset consists of like 53,198 samples in the training set, and a few numbers around 3,000 both in the validation and the test sets. However, the number of data sets were increased in review for repair, but since we are using this PL-BART and code T5, which has the input token of only 512, so some of the examples were being removed. And in this case, the buggy code had two special tokens. The first one is like the start focus and the end focus in order to check where the code block is there. And similarly, like for the Tufano et al. Dataset, they have this start comment and end comment. As you can see in this, it's similar like this. Just the difference is that for the Tufano, it's start, and for the review for dataset, it is start focus. All these two data sets consist of the insert and delete and date update things, where and this like it is this two data set is classified into insert, delete, and update, where insertion just takes up like adding some code blocks, and deleting of some of the code blocks, whereas update means both insertion and the deletion. I forgot to mention in the previous slide that For the Tufano dataset, it has been collected from the Gerrit and GitHub both, and whereas for the review for repair, it has been collected only from the Gerrit. And moving on towards the second research question about the prompt engineering for APR. So they have used two large language models, ChatGPT 3.5 and CodeDaVinci Edit 0.001, which I have mentioned about. It's a Codex version, and they have used both zero shot and a few shot prompting. However, for the Codex variant, they have not used the few shot prompting because this is an instruction based large language model, and it has a fixed format where the format is of like input, instruction, and output, where in the input they have used they have given the Buggy code, and for the output they have just used like refactored the code with the using the code review, and they have given the code review, and the output is the um, correct code. Whereas for the chat GPT, we can use this few shot prompting in order to slightly tell the large language models how the model should look like. And so for the chat GPT, the zero shot and the few shot prompting has been used, and for the codex variant, only the zero shot prompting is used. However, for the few shot prompting for the chat GPT, they have selected in such a way that they have first vectorized it, and then they calculated the cosine similarities of the codes, and then they selected the three best rankings, and that's how the three best codes have been used for the few shot prompting. And then since ChatGPT has a tendency of outputting various extra informations which we don't want, so we have to apply some kind of algorithm or heuristic based analysis in order to generate the correct format. So the there are like few things that they have done. The first one is the adjusting the space. In here they have removed the extra spaces and extra new lines if the ChatGPT is printing it out. And the second one is the code explanation removal, where they have like code ChatGPT often tends to explain their reason of the code modification. So they have removed specific keywords such as like explanation, reasoning, etc. And since this is just a Java code, so they have removed so it generally tends to start with, okay, you're given Java code. So they have removed the word Java, and they have like removed those unnecessary redundant keywords such as like refactor or corrected code or updated version, etc. types of words, and words plus their whole block. And they have removed the backticks. They have instead of using the start and the end special tokens, they have just started using three backticks. So we have removed this backticks also in order to get match the data set. So the third research question was about the developer analysis of generated repairs. So there are two reviewers who will be analyzing it. So the first they have done is like they have just collected 314 test samples from the Tufano dataset and 340 test samples from the review for repair dataset. And then because they have considered the 5 models, the first the top one solution for PLBART and Code T5, and zero shot and few shot prompts for both the large language models, and with applying and without applying the heuristics. And so the way how the reviewers analyzed is, if the code is able to fulfill the code review requirements, then they have rated 1. Otherwise, they have rated 0. And they have even calculated the Cohen's kappa score, which I'll discuss about it in the experimental sections. This is all about the methodology. Is there any question? If no, moving towards the experimental results. So for the first, before I start going on with the experimental results, so there you can see there are two model names, R4RCC and Tufano 2 encoder. These two models have been done have been referred by from the Tufano paper and the review for repair paper, where the data sets have been collected as the baseline. So R4R CC refers to the code use of the code for a code review, where R4R model was the sequence to sequence model, and Tufano to encoder refers to the use of code review using the transformer based model. And the rest two models are PL-BART and CodeT5. And here they have calculated three types of accuracy. The first one is top 1 and top 5 and top 10. And they have calculated the blue 4 scores and the code blue scores. And as you can see that CodeT5 is performing better than the PL-BART. This could be due to that CodeT5 has comparatively better natural language and programming languages capability, and hence it is achieving better accuracy than the PL-BART. But however, you can see that both the models PL-BART and CodeT5 are outperforming the baseline models of both the data sets, and hence we can say that okay, the code review is helpful in increasing the efficiency or the accuracy of the repair. And yeah, as I mentioned that this each data set has these three classes: the insert class, update, and the delete class. So you can observe that here also with just a blind glance that CodeT5 is performing better in I think almost all the cases except for one. Checking out with one by one. So with insert class, even the CodeT5 is performing better, and this is because insertion and update is difficult than deletion. And for the deletion part, which is like figure C and F, you can see that PL-BART is slightly performing better than CodeT5 due to its because this is an easy task. Whereas for just for the delete class in the review for repair dataset, figure number C, the baseline model is outperforming all the other CodeT5 and CodeT5 and PL-BART. And however, but for the update class, which is the most hardest one, where insertion and deletion both take place, CodeT5 is performing the best, and hence the overall performance of the CodeT5 is increasing in the previous chart, previous table. And then they have compared for referring to the research question number 2, where they have utilized this large language models with the zero and the few shot promptings. So as I mentioned before, that this Code Da Vinci edit is the instruction based, and hence few shot could not be used. And if the few shot is not being used, then we don't need and since it's an instruction based, so we don't need to apply the heuristic. So that's why there are 5 types of experiments. So with and without heuristics for the ChatGPT style. So you can see that, we can observe that without heuristics, the number is very low, and hence the heuristic is needed in order to match the style. And also we can observe that the instruction based is able to perform much more better for the Tufano et al. Data set. The reason for this is this specific data set performing better is that this data set was published before September 2021, where the ChatGPT data set has still all the data up to September 2021, whereas review for repair has been published after September 2021, and hence they assume that there could be some kind of data leaks, but since these large language models are black box, so they could not check whether there is some kind of data leaks or not. But the figures suggest that okay, there might be some kind of data leaks into it, and even we can even observe that this codex is performing better than the CodeT5 also. And the next research question was about the developer analysis on the repaired codes. So they have compared about there are 2 reviewers. This 2 refers to the 2 reviewers, and this one side is for one reviewer and the other side is for the another reviewer. So for the fulfilling and not fulfilling is based on like whether they are like whether they were able to fulfill the code review of the code review suggested or not. The difference between two reviewers is possibly due to uh, like due to the like one of the reviewer also accepted if it's not enclosed into the special token like start and end, but the other reviewer did not consider that if it's not enclosed into the start and the end, and that's why there is slightly disagreement between the two reviewers and even between the figures. But we can even observe that with both the reviewers that Code T5 model is performing better, and as well as like if the Codex is performing better than ChatGPT than that was suggested in the previous experimental results. So this is all about my presentation. Like, so the conclusion could be like they have basically compared about two pre-trained models for better automated program repair for the Code T5 and field part, and have showed that both the pre-trained models are able to outperform better with the baseline with from the baseline with the use of code review, and however Code T5 was performing better, and similarly large language models also showed great promises with the prompting techniques, but whereas the instruction-based codex variant was performing better, but with the Tufano where the data leakage could be possibility, and then they have like manually analyzed also and showed that okay, this there were some like things which they were not able to fulfill the intention of the review. So this was all about my presentation. Is there any questions?
발표 감사합니다. 예, 질문 부탁드리겠습니다. 컨클루전에 보면 저 GPT랑 저 코드 다빈치가 저거 지금 코덱스 모델 말하는 건가요?
Yes, sir. It's the variant of Codex.
그 프롬프팅 테크닉에 대해서 굉장히 뭔가 전망이 좋다 이렇게 써 있는데 어떤 프롬프팅을 말하는 걸까요?
Sir, they have not used any specific techniques, just that they have just used the like for the few shot with the ChatGPT they have used the few shot by using this vectorizing and then getting the similarity the three best rankings, and then that's what they are referring to for the ChatGPT 3, and for the Codex they have just used for the instruction prompt that they have given refactor the code using a code review by using the given code review. So that's all that they are using for the prompting techniques.
근데 그게 그 프로미스
Yeah. Sir, the reason why they have said about the GPT and the Codex is that because they were able to perform like better, like you can see here, like 28% and 40% from the baseline stuffs, like which was just 19.59 and 12.16. This I thought that's why they have mentioned that large language models are performing better.
그러면은 그 퓨샷을 했을 때 성능이 오히려 안 좋아지는 거에 대해서 설명이 있나요?
No, sir. They have not mentioned about that.
네, 그 챗에 질문이 하나 올라와 있습니다.
Okay, sir.
뭐 딜리트가 저렇게 높은 성능이 나오는 게 왜 가능한 건가요?
Sir, that's because they said that for the baseline models, because they have used this transformer and the um, for this repair for they have used the sequence to sequence, and they said that delete is the most easiest one. That's why the baseline was more higher, but like they kind of ignored that figure, and they just said that okay, just this only for the delete, for just for the review for repair data set is showing this much. And I kind of felt that they are not sure about this result also, because the Tufano data set did not show that much of high accuracy.
네, 저거는 그러니까 뭐 단순히 쉽다라는 말 말고는 뭐 아무런 이유가 없는 건가요, 그냥?
Yes, sir. So, but I personally doubt these figures, because I mean, I do not understand like why review for dataset repair was like that much high, but on the other hand, for the Tufano, the same delete is not being performing well. But then, like I thought that the first one is for the sequence to sequence model, and the second one is the transformer based. So, but sir, like I felt like transformer based model should perform better than the sequence to sequence, right, sir?
네, 제가 보기엔 저건 뭔가 모델의 문제가 아니라 데이터셋의 문제 같긴 한데, 네, 저 리뷰 포 리페어라는 데이터셋이 어떻게 생겼는지 혹시 보여주셨나요?
Sir, they have just said that this type of data set is there, where the simple codes are only there, where they have to just modify some of the codes only. They
이게
have
지금
not shown
리뷰 포 리페어
the
데이터셋인가요?
sir. This is the Tufano data set, but they have not mentioned about review for repair data set, and I was not able to find it even in the websites.
아, 네, 알겠습니다. 네. 혹시 더 질문 있으실까요?
Um, but sir, I think the length of the both the data sets tokens were like almost around like 520 tokens only, and the output was like around 200 tokens.
예, 예, 근데 뭐 토큰 수가 비슷하더라도 실험 결과가 너무 달라서 이게
Yes, sir.
그 부분에 대해서 이해하려면 데이터셋이 어떻게 생겼는지 뭐 이런 걸 봐야 될 것 같습니다. 그, 네, 한번 채세 질문이 하나 더 있습니다.
Main advantage compared. Like the main advantage what they have showed is that this could, like the first one is that with the baselines, the figures are increasing. I mean um, even with the use of code review, some slightly there was a change of figures between every kind of data sets, even with the baseline models without the code review. And the second one was that with the help of code review, because it's being done manually, so we actually know what's wrong with the code, and so we can exactly tell, okay, this is the problem, like individually with each problem. Compare their method again. No, they have not compared their methods against the unit test.
네, 혹시 더 질문 있으실까요? 네, 오늘도 예, 질문이 별로 없는데, 어, 네, 그 유닛 테스트를 사용을 하면 뭐 더 좋은 피드백을 줄 수 있지 않을까 이런 의견이신 것 같아요. 네네. 혹시 그거에 대해서 뭐 답변하실 만한 내용이 있을까요?
Uh, what I felt was if we use this unit test or test suits, um, like we are not specifically like telling, okay, this is the problem, especially if in the case of large language models, sometimes it's difficult for the test suits to understand, to understand what actually it is going. But if we give a clear, like, written instruction, it's easier for the large language models. This is like just my view on it.
알겠습니다. 혹시 뭐 마지막으로 이 논문을 선택하신 이유라던가 뭐 이 주제 관련해서
Um,
뭐 진행하고 계신 연구가 있으면은 뭐 그런 걸 설명해 주셔도 좋을 것 같습니다.
the reason for me why I choose this paper is like, firstly, like I was doing a research on this automated program repair also, and then I went on with this test case generation, code complexities, and all, using this large language models. And so the prompt engineering is the main focus on it. So I thought, like, this came up with a new idea of like code review, where I have not seen people utilizing the code review. They were using this test suits and all stuff. So I felt like with the use of this code review and explicitly telling the large language models to how it is being, like, what are the issues, and how can we correct it, especially with the few shot prompting. It's like it's a good research topic to go with. Like, that's the reason why I chose it.
네, 네, 감사합니다. 네. 혹시 더 질문 있을까요? 네, 질문이 만약에 없으시면 여기서 마무리하도록 하겠습니다. 오늘 발표 준비해 주신 아디티 학생 고생 많으셨고요. 예, 그러면